Next up is going to be Erin Atkinson with Halff Associates. He's going to talk to us about Groundwater Conservation District databases, the importance. I'm not sure all exactly what he's going to talk about, but he's got a great deal of experience, and we'll turn it over to Erin. 25 minutes.
Thank you, Alan. We'll try and do it in 20. Okay. How's everybody doing today? Enjoying the conference? Getting a lot out of it? All right. Well, as Alan said, my name is Erin Atkinson. I've been with Halff for about 18 years now, and about 8 or 9 years ago, we got the opportunity to start building groundwater databases. Since that time, we've done 15 of them now, so kind of the perspective I'm going to be presenting today is kind of some of the lessons learned, things to look out for if you're thinking about moving towards a database and putting that together. That's right. Ready? All right. So just real quick, kind of agenda we're going to go through. I'm going to kind of start at the high level and then slowly work down into the details. So talking about, defining some of your goals, what kind of existing data do you have to work with, how do you want to organize that, and ultimately start wrapping some database rules and logic to make it do some reporting from you. If you're thinking about moving towards having a database, I'm assuming you're wanting to improve your current position. Otherwise, you can be perfectly happy with what you have. But the ultimate goal of having a database is to ask it questions and be able to extract that information so that you can help out your well owners or general public information requests. Then we'll kind of wrap up with some final thoughts, and I'll take any questions. So, database goals. If you're thinking about doing this, sit down and ask yourself some questions. What I have learned from working with 15 districts is everybody's unique. You all have your own district rules, you have local needs, and so you want to go through and decide what's going to work best for you. So sit down and think about the information you need to collect. Are you focused on permits? Are you focused on water levels? What information do you need to pull together? A database does not need to be highly complex. You don't need to take into account storing every piece of information under the sun. We'll have a hub that we can reach out to get other pieces of information later. But what do you need to do to meet your management goals? Do you need to have a map? At my heart, I'm a GIS geek. If you don't have a map, you've got something wrong with your system. But you can have a groundwater database that doesn't have a map. If you just want to manage the information that's in there, looking at water levels, tracking your DFCs, you could do that without having a map. But if you are going to have a map, what are you going to do with it? Do you have permit spacing requirements? Do you need to know the distance to a property line or the distance to an existing well that's already in a given aquifer formation that the proposed well wants to go to? What information do you want to put in there? Do you want the public to be able to see any of this information? How many questions could you avoid if you had some publicly facing portion of your database so that they could just open it up, look at it, and answer their own questions? Ultimately, like I mentioned, I'm assuming you want to be able to report something out of your database. You want to be able to extract that. So, what are those reporting needs going to be? Do you need to produce a report for your, monthly board packet? Are you trying to monitor overall production levels? So think about what's going to be going into that. And finally, how are you going to access it? Do you want a desktop application that's just running on your local computer in the office? Or do you want it to be web-based so that you can sit here and check your water levels like Alan's probably doing over there? He tends to look at his phone all the time and check on his database. So, how do you want to get at that? But ultimately, you're going to put together an action plan. This action plan does not have to be 100%. You don't have to know all the different answers to your questions, but it should give you some overall guiding principles on what you want to put together so that, kind of a scope of work. Where do you want to start, and you can keep it going. Like I said, it doesn't have to be highly complex. You just need to know how you're going to put it together. But I will advise, don't back yourself into a corner. Make sure it's flexible. District rules change, your needs change. Make sure you can change your database too as you're going along. So what are you starting with? Do you have hard copy files? Do you have a room dedicated at your office that has all the paper applications that you need to figure out how to turn that into digital information? Have you already started putting into it Microsoft Excel files, spreadsheets, or maybe an Access database? There's lots of different ways that people have stored information. And the Texas Water Development Board has a wealth of knowledge in their groundwater database. You can start with that to seed what you want to do. Maybe you want to pull in their information and start modifying and updating it at the local level as opposed to what the state's housing. So you need to take a look at what you're going to be starting with. If you are starting with hard copies, what do you need to pull out of that information? You've got applications for drillings and permitting. What do you want to be able to search the database for? Obviously, a well owner or the driller might be important, but just because you collect maybe the proposed well depth, is that something you're going to search for later on in the database? The actual well depth after it was drilled might be more important. You can always take these hard copy files, scan them to PDF, and attach them to the database. So if you need to go back and reference that somebody said, I really want to drill to 300 feet, and they actually drilled to 500 feet, you could look at that later. But as far as searching the database and being able to ask the questions, you don't necessarily have to transfer every piece of information that was collected on a hard copy form into the database. Only take in what you want to manage. Don't give yourself more work than you need. If you do happen to have existing digital data, whether it's a spreadsheet or maybe an Access database, how complete is it? Are you collecting information that you need? Are you missing pieces? Did you inherit a spreadsheet because the general manager changed and the previous regime had some ideas and you've decided to go a different direction? Or do you have fields in there that you no longer want to collect? Are there fields that you would like to collect? Think about how you want to put this together and collect it and move forward. Again, don't create work that you don't need. From a database perspective, having empty data fields will lead to confusion. Somebody will wonder, why aren't we collecting that information? If you're thinking about moving to a database, here's a great opportunity to kind of get rid of the unwanted fat, trim it off, and get it out of the way. The other thing you need to look at is how clean your data is. I mentioned that everybody's unique, but one consistency is the data is typically not very clean. We spend most of our time in prepping a database, going through it and trying to clean things up. Spreadsheets, typically you store everything in one row all the way across. And so you've got, well number 1, and it was drilled by Acme Drilling, and it goes across, and then well number 2 was also drilled by Acme, and it just keeps on going. When we go to a database, depending on how you store that information, they can be the same or they'll be unique. The example here, I think we could all look at the screen and agree that the drilling company was Ace Water Wells. But depending on how you put that in there with typos, even punctuation, the difference between ink with a period or without a period, from the computer standpoint, those are unique records. When we import that in, do you want this Ace Water Wells to be treated as one driller's record, or do you want it to be treated as 4? This is what I'm referring to when we're talking about data cleanup. It's very easy to see it, especially in Excel. You can start sorting and do a copy paste and make them all the same. But that's where most of the districts spend a lot of time trying to normalize their information when they're heading for a database. If you are going to have a mapping component, do you have coordinates that represent where the wells are? How good are those coordinates? Or maybe just have a physical address, 123 Main Street, and that's where it's located. But do you have something that describes where that well should be in the physical world? And then when you start looking at it, how good are those coordinates? We can all agree that if your latitude, longitude is 2 blanks in the database, it doesn't exist. It's floating out in space. 0, 0 is even worse because we're probably not throwing it out at the equator. But how are you going to deal with that? When you start cleaning it up, putting it on a map, looking at it, does it fall within your district boundaries? Now, you may well track some wells that are not within your district because maybe it's a monitoring well that you want to keep track of. But in this case, like circled out there on the right-hand side, those are just wells that didn't have good coordinates and they just kind of got thrown out there. They're near the district, but we don't actually know where they sit. And so that starts tying into, do you understand what the spatial reference is of your data? Most districts have collected things with geographic coordinates, whether it be decimal degrees or degrees, minutes, seconds. Again, going back to the cleanliness of your data, a negative sign in front of the longitude is critical. If it's positive, you're actually in the eastern hemisphere. You need to make sure that it's dropping in the correct location. You may also be using a reference system that you want to use units of feet, so maybe you're using a state plane coordinate system or maybe the GAM model, that custom projection system, because you want to reference things from in distance of feet or miles as opposed to, how far is 1 decimal degree. Most people don't operate in that sense. So going through and looking at that data, determining how clean it is, but ultimately you do want to standardize on one. Now, if you need to tell people, report back, here's the well location in degrees, minutes, seconds, you can do a lot of things with the database and let those things be automatically calculated, but you only want to be entering one set of coordinates. It helps keep the database clean when you're moving forward. So you've got your existing data. Now how are you going to organize it? We like to think of building the database around a key feature. That key feature can be whatever is important to the district, what your management needs are. Typically, things will kind of revolve around either the wells or maybe the permits or maybe the owners. Again, it's going to depend on how you want to report the information back to it. But taking a look at it and deciding, what we're going to let the center of the universe be is important for your planning aspect. How do you want to put it together? Because again, when you start reporting the information, are you going to key off of a well or are you going to key off a permit? It doesn't have to be only one of these, but usually one of those three is what we end up looking at. But it will assist you later on when you're pulling information out. The next part is defining your database structure. We like to break everything into individual tables. Rather than putting ownership information directly on the well, we will have a table for wells, a table for owners, a table for permits. We can put all that information back together and establish the relationships, but this allows us to really start using the benefits of a database. If you have an ownership table and somebody lets you know that their contact address has changed, rather than going in and finding every time John Doe put in a well and go change all those different places for his physical address, you can go to one record and change it in one place, and that takes care of the entire database. So separating all the information out really makes it convenient, not only for the permits and wells, but also your water quality, water level information, and anything else you've decided to collect. The next step, after you've decided what all the tables you want, is to build up the relationships. Now we're really starting to get into the power and the benefits of using a full-blown database. You can establish, one-to-one, one-to-many, many-to-many if you want to get in trouble, but how are all those different tables going to tie together? When you're doing this, again, you want to kind of ask the questions of the way in which you're going to manage your district resources. Can a well have one or more than one permits? And vice versa, can a permit have one or more than one wells? How are those going to tie together? How are you going to report your production information? Do you want to report it at the well level, or do you want to report it at the permit level? If you're going back and updating your GAM model and you've only stored production information at an aggregated, maybe it's a public water supply and they've got 5 wells and you're reporting it for that entity, how do you know how much water was pulled out of a given aquifer formation or at a given location? So you want to think through how you want to store your information. Again, how we extract it later on, we've got a lot of opportunities, but you do want to structure the database so that you're putting the information in that makes sense for the way in which you're managing your district. Next is working on the rules and logic. So this is what helps you maintain a database with high integrity. We can do a lot of different things. They can be very simple. Going back to the coordinates, if you have a mapping component, you know where your district is. You can define what the bounding coordinates of your district boundary is. And so when you're typing in the coordinates for a proposed well or a new well that's been drilled, do those coordinates even fall within the district boundaries? We can have the database tell you, hey, this isn't within the boundary. Maybe you forgot the negative on the longitude, or you typoed, 33.1, you put in 331. And so it's just a bad coordinate. It's just a quick check to make sure you're falling within the district boundaries. The other thing we use a lot of is drop-down lists, or maintenance tables, if you will. This cuts down on the number of typos or erroneous data or preferences. So, you can have a well use of agriculture. Somebody likes to say and type in agriculture. Somebody else might be a little bit lazy and type in ag. But if you use a drop-down list, you can define what is that value that it should be. That way it's consistent throughout the entire database. Because remember, if we actually let the database have an agriculture and an ag, those are two different well uses from the perspective of the computer and what the database is going to see. So drop-down lists can help you do that. It also reduces carpal tunnel, less typing, and you can define what all you want to put in there. You're not set on these. If a new well use comes up, you have a maintenance table, you can go in, add new values, but you're deciding this is the one way that we're going to record different values, whether they be aquifers or well use or well status. Let the database do what databases do. They can do a lot of auto calculations. So if you're going to be storing production, both you want to see things in gallons and acre feet, decide which one you want to type in, but let the database do the calculation for the other one. That way you're not typing in two numbers and potentially, maybe you typoed when you're coming off your calculator when you did the conversion. Just let the database take care of that for you. Along a similar line is if you have permits and your permits expire, if you have a predetermined permit term of 2 years or 5 years, depending on the type of permit, when you put in that original permit date, let the database calculate that expiration date for you. You can use that expiration date later on to notify people when their permits are about to expire, so you can be proactive about working with your well owners, letting them know that they need to come in and update those permits. These are very simple things that you can implement within a database sense that will help you maintain that clean database. You want to prevent the mistakes, you want to prevent the erroneous data going in. And I do like to advise everybody, try to avoid the exceptions. The worst thing we like to hear is when they say, well, most of the time this is the way it works. Well, most of the time is not good enough. From a database, it needs to be all the time. Because what happens is you can't program an exception. If you're going to have an exception, well, it's really not an exception. We have to let the whole database understand that this is a possibility. So we do like to get very detailed on what are we going to allow the database to do, which will, again, prevent problems in the future. So we've gone through all the geek stuff. You actually finally got to the point where you're actually pulling information out. We refer to it as reporting. But reporting can take a lot of different aspects. We can present it in a lot of different ways. Typically, we have something we call a dashboard. It's a real high-level look at what's going on with the district. Maybe you want to see how much production has been reported this month, or how much production has been reported against a given aquifer. As you put in more and more information into your database, the dashboard is just dynamically updated. It's always reading the most recent information. So if the general manager's just looking at it, but you have some field technicians that are entering all their water levels, that information is coming through immediately. It's all real time, and you can see at a high level what's going on with the district. You can do pie charts and graphs and charts and everything on how you want to represent it. And again, these are always built around what are the needs of the district. Everybody's got some unique aspects on what they want to see, but we can present that information in lots of different ways. When you're using a database, being able to roll up information is a very simple thing to do. If you have some DFC monitoring, we're really good at building databases. We're not the hydrologist, but if your hydrologist has defined some equations on how water levels tie back to your DFC goals, as those field technicians are out there doing water level measurements and they're going in, we can, again, present it in a table that shows here's the most recent water level measurements, implement that equation that they've come up with, and show here's where you are as you're moving forward through time and whether or not you're meeting your DFC goals. A more traditional aspect of reporting is I just want a button, I want to click on it, and I want to produce a PDF file. If you have standard things that you want to put in a monthly board packet, so here's all the production that's been reported or the water levels that have been collected, and it always looks the same, we refer to that as standard reporting. Very easy to create. You click the button, it produces a PDF file, you print it, and away you go. Another aspect that comes into play with, especially with public information requests, is random questions that you never expected to hear, but yet here it is. So if you have something like this, which we refer to as an ad hoc query tool, it exposes the entire database. So everything that you're storing, you have access to. You can build your own little question to the database, a query, execute it. It comes back out as an Excel file. You can quickly respond to the information that's being requested, send it back to them, and provide that information. You can also do it for your own analysis. Because it's coming out as Excel, maybe you need to do your own graphs or charts. You're trying to present something to your board and show them what's going on. This is a great way to access the database and extract that information back out so you can use it. And finally, the last aspect I'll touch on with regards to reporting is the notification side. When our permit's about to expire, you can have just a little summary table showing when those are coming up. This example is what's going on with applications. So you log in the morning, you want to know which ones you need to be taken care of. These are all the current applications that are coming up for something to happen. Maybe you need to contact them because they owe you a driller's log. They've exceeded their 60-day policy and they're no longer going to get their refund, but you can use this to kind of report back from the database without having to do a query every time. You can build this in to help make your life a little bit easier. So just to kind of wrap up with some final thoughts. When you're going to build a database, hopefully you're doing this for the right purpose. You want to make your life easier, and you want to have cleaner data, and you want to be more proactive about being able to collect all the information so you can manage the district's resources. But who's going to be using it? Is it just district staff? Do you want the public to be able to see the information? Do you want to have registered users? So do you want your well owners to be able to log in and self-report production information or water quality, what have you? And if you are going to allow other people outside the district to log in, what kind of restrictions do you want to put on them? Can they view it? Can they edit it? Can they delete information? I wouldn't recommend that, but you can decide how much access you want to give out. It's great for when you have your engineering consultants that need to pull out the information because they're going to update the GAM model. So they can pull the information that they need directly out of the database. It's the most up-to-date that you have, and then they can be more efficient on doing their analysis. How many data editors are you going to have at a single time? If there's just one person that works for the district and that's the only person that's going to be editing it, an Access database might be great, but it is limited to one person at a time. And so I have heard stories where, one person gets to use the Access database in the morning, the other person gets to use it in the afternoon. Doesn't seem very efficient, but Access is a real database, and you can set up all the rules and logics and structures that we've talked about within it. But do you need to go a little bit further? If you're thinking about going to the web and having a web presence and you want to be able to access all the information from tablets and laptops and wherever you're located, you're definitely going to have to go above an Access database and move to a MySQL or a SQL Server or something like that. And if you are going to do that, are you going to host it at your office, or are you looking for a third-party hosting solution? So who's going to take care of the backups and maintenance of everything? So as you're moving those directions, these are some of the questions that you're going to have to answer to get to work. I will say that there's quite a few districts out there that have databases now. Talk to your sister districts if you're interested in going there. Maybe they'll let you take their database for a test drive. It'll give you some good ideas on what the possibilities are and how you want to proceed forward if you're heading down the road to building a database. So with that, I appreciate it, and I'd be happy to answer any questions.
Any questions for Erin?
All right. Thank you very much.
Thank you, Erin.